So now that you know a thing or two about arrays, we're going to start looking at some more advanced techniques like searching for values in arrays, looking for highest and lowest values in numeric arrays, and sorting arrays as well, alphabetically or numerically. So in this program, in this video, we're going to do what we call a linear search of an array. And this is a very simple technique. It's fine for small arrays such as this one. This is not a technique you would use with a very large array with thousands and thousands of elements. But for 10 elements, this is fine. And by linear search, we just mean we're going to look for a value in this array. For example, coffee. I've hard-coded coffee as our search term in this array. And a linear search just means we're starting at the first one. We're saying, is this coffee? No, it's chocolate. Let's move on to the next one. Is this coffee? No, it's vanilla. Move on to the next one. So you just basically start at the top and you examine every element in order until you come across the one you're looking for. Or maybe it's not in there and you won't come across it. But that's a linear search. It's just a very straightforward technique of searching the array literally from top to bottom. Okay, so you see we have our array of flavors, and we have a const for the max flavors, which I've hard-coded as 10. And then I have a string. This is the flavor that we're going to search for. I've chosen coffee. And this is, if we find what we're looking for, and we're going to because coffee is in there, but if we find what we're looking for, I want to isolate the index and just tell the user, okay, we found this at index 6 or 7 or wherever it is. Give the user an idea where this value is in the array. And so I have this integer, which is the found at index. I initialized it to -1 only because if I were to initialize it to 0, which is kind of a typical initialization value for a numeric variable, the problem is this is actually an index in the array, with 0, which is the index of chocolate. So that's not really a good starting value for this one because we don't know that we found what we're looking for. So we don't want to provide an actual index of the array as the initialization value. So -1 is definitely not an index in that array, and that's why I've chosen it. And then I have a Boolean to indicate whether or not we have found the value. That's going to come in handy. And I've initialized it to false because when we hit run and the program first runs, we haven't found it yet. So it should be false. We'll flip that switch, so to speak, and initialize it or assign it a value of true if we find what we're looking for. Okay, so what we have here is basically a loop. We're going to loop through the array, as I said, top to bottom. All right, and so I've looped the array to start at 0, obviously that first element in the array, which has an index or a subscript of 0. And I'm going to keep going while my loop counter I is less than the max flavors, which is 10 flavors in this case. And I'm going to also add to this, I'm going to keep going while the item has not been found. Recall that the exclamation point is negation in C++. So I'm saying keep going while we still haven't reached the max number of flavors and we haven't found the thing we're looking for. That's what that translates to. And then our increment, of course. So inside the loop, we have an if statement, and we're saying, okay, the current thing that we're looking for, the current element that we're looking at, starting at the top and looping through this array using the loop counter as the array index, if this current value that we're looking for, or looking at, I should say, is equal to what we're looking for, the search flavor, hard-coded coffee in this program, if the current element we're looking for is equal to coffee, then boom, we found it. We're going to isolate the index at which we found it, which is the loop counter as array index. And we're also going to flip the switch on this flag variable. And because the found value should be set to true. We found what we're looking for. And that's it. So that will, if we find the value wherever we find it, even if we found it right off the bat, I mean, it's deeper. In this case, the coffee is kind of far down at the bottom. But as soon as you find what you're looking for, that's going to terminate the loop because we've coded it to only keep looking while not found. Only keep looping while not found. And then as soon as that becomes true, boom, this condition is going to become false and the loop ends. So that's nice. It's efficient, even though this linear search is, in the grand scheme of things, not an efficient way of searching an array. But there's no point in looping through the whole thing. If you found what you're looking for, you're done, and the loop should stop at that point. Okay, and that's that. And then now here I just did a little thing at the bottom. If the value is found. Now look at the way I use the Boolean. We could do this as well. Okay, that's a very unusual, it's almost like an amateurish way to use a Boolean variable. Recall that a condition, a relational expression in an if statement or in a loop is going to evaluate to true or false. Now, in the case of a Boolean, it's true or false anyway. You're already there. You don't have to go the extra mile. It's redundant to say this because whatever is in here is a true or a false. So this would translate to true equals true or false equals true. I mean, it's redundant. So like I said, it's way more common to see a Boolean value in a condition just standing by itself like that because they can in that regard. Okay, so if we found it, then we're going to say it's been found at whatever index. And or else, if we haven't found it, we're going to say what that thing was not found. So let me go ahead and run that. Okay, and we see the coffee has been found at index 7, which would be the 8th element in the array.